Welcome to this video. So in this video, we're going to be looking at tutorial sheet 6, which is on sampling distributions and estimation. So we have about 4 questions in this tutorial sheet. We're going to solve all of them. Okay, let's start with question 1. Question 1, they're saying, in a survey conducted by a hospital pharmacy, a random sample of 200 patients yielded 172 who indicated that they were highly satisfied with the delivery time of their prescribed medication. Number 1, calculate an approximate 95% confidence interval for the proportion of patients who are highly satisfied with the pharmacist's delivery. So here we are calculating a confidence interval for a proportion. Okay, so the formula is given by the proportion, okay, which is p hat, and then plus or minus the z value, okay, at alpha divided by 2, and then the square root of the proportion, and then 1 minus the proportion divided by n. Okay, so this proportion p hat is found by the favorable outcomes divided by the total number of people that are in that sample. So here the favorable are 172. The total number is 200. So I'm going to divide 172 divided by 200. So in my calculator, this gives what? So that is 172 divided by 200. This gives 0.86. So that is my proportion. Okay, and then in this proportion, we can see that we have n. So n is just the 200. And then I can also see I have this guy here. Okay, so this guy depends on the confidence interval that you've been given. So this guy is called the z-score. Okay, it's called the z-score, and it will be dependent on the confidence level that you've been given. So here we've been given a 95% confidence level. Okay, so whenever you see a 95% confidence level, then when you convert it to a z-score, it's going to be what? 1.96. Okay, so let's find this confidence interval. So we're going to say confidence interval is equals to the p hat was 0.86 plus or minus. And then here I'm going to say this z-score. In fact, before you even get the value, the 1.6, you have to find this alpha. So how do you find alpha? So alpha is equals to 1 minus it, okay, minus it, the confidence interval divided by 100. So the confidence interval there is 95. I divide this by 100. So this will be 1 minus C. This will be 0.95. Okay, that will be 0.05. So that will be my alpha. So here I'll write Z, the alpha over 2, but the alpha is 0.05 divided by 2, and then the square root of the proportion. And then in the brackets, I have 1 minus the same proportion, then divided by what? 200. So this is what I have. Okay. Now, by the fact that this alpha came from the 95% confidence interval, then we're just going to replace it with the 1.9. So this will be 0.86 plus or minus 1.96. Okay. And then the square root of whatever we have here multiplied by. So what is 1 minus 0.86? So 1 minus 0.86 is 0.14. And then I'm dividing this by 200. Okay, so what is remaining here is to find whatever I have here, and then I add and subtract from this. Okay, I add and subtract from that. So let's find what we have here. So I'll say, let's erase this part. So I'll say the confidence interval is equals to 0.86 plus or minus. And then here I have, okay, so I'll start with what is outside. So 1.96 multiplied by, and then I'm going to put the square root of, and then I'll put those things in brackets. So it will be 0.86 multiplied by 0.14. Okay, and then I divide by 200. Okay, so when I do that, okay, I get 0.048, 0.048 0, okay, and then 9. So that is what I get. So it means my confidence interval will just be equals to, oh, curved brackets. So the value that will be here will be 0.86 minus, okay, 0.86 minus 0.04809. So that will give me 0.81191, comma, and then now I'm going to say 0.86 plus 0.04809. So this gives me 0.90809. So this is my confidence interval here. Okay, so the confidence interval is given by this. So you can round it off to 3 significant figures. Then it's going to be the confidence interval is equals to 0.8112, comma, okay. Okay, 0.812, and then this will be 0.908. If I round them off to 3 significant figures. Okay, so these numbers here, there's my 0 point something. You can also represent them in terms of a percent. So if I multiply this um by 100, what do you think I get? Okay, what do you think I get? I'm going to get okay, so that would be 81. Okay, so that would be 81.2%, comma, the other one would be 90.80%. So you can represent it like this, or you can represent it as this. There's no problem. Okay, so that was part 1. We found the confidence interval. And then part B, okay, part B, they're saying, what are they saying, part B? Part B, they're saying comment on the likelihood that more than 50% of the patients will be highly satisfied with the pharmacist's delivery at times on a particular day. Okay, so 50%, I'm comparing it with this interval here. No wonder I was even putting it in percentages. So you see that in this interval, I do not have a 50%. Okay, I do not have a 50%. So the confidence interval, okay, this confidence interval at the 85%, okay, is way above, the 50. Okay, is way above the 50%, because the lower bound of that confidence interval is 81.2%. Okay, so it's way above the 50%. So conclusion is that it is very likely, okay, meaning that we have strong evidence that more than 50 patients are highly satisfied on a given day. Okay, because the 50% here is way lower than this. So they said here that we should comment on the likelihood that more than 50%, okay, will be highly satisfied with the farmer's delivery on a particular day. So based on this confidence interval, we see that 50, okay, the confidence interval at 95% is way higher than the 50%, meaning that it is very likely, okay, for for the patients to be highly satisfied on a particular day. Okay, so that's what it means there. Okay, and then we go to part B. So this is question 1, part B. So part B, they're saying a random sample of 800 nurses was surveyed to determine the proportion, okay, who experienced work-related back pain in the past year. Okay, and 320 of them reported having experienced such pain. Okay, so you can see here the N is simply my 800, and then the favorable, the ones that to experience pain are 320. So you can easily find the proportion using that. So the first thing is construct an approximate 99% confidence interval for the proportion of nurses in the population who experienced work-related what? Pain. So we're going to use the same formula. So it will be confidence interval is equals to, okay, the proportion plus or minus the z-score at alpha divided by 2, and then the square root of the proportion 1 minus the proportion divided by the n. Okay, so what is the proportion? The proportion is 320 divided by 800. So this gives me what? The 320 divided by 800 gives me 0.4. Okay, my n is 800. And then I need to find this one now. So my alpha here will be, okay, 1 minus 99 over 100. So this will just be 1 minus 0.99. So this will be 0.01. So there it will be alpha over 2. So this is 0.01 over 2, which will just be what now? 0.01 divided by 2. That's the value. It's going to be 0.005. So that's what I have. Okay. Right. So now let's replace and find the confidence interval on part 1. So this means the confidence interval will be equals to the proportion 0.4 plus or minus the value of this, because we are using 99% confidence interval, it will just be what? 2.575. So here I'll put 2.575, okay, and then multiplied by 0.4, and then 1 minus 0.4 is 0.6 divided by 800. Okay, so what are we going to get there? Okay, so this will be 0.4 plus or minus 4. I mean 2.275 multiplied by whatever we have in the square root. Okay, I'm getting 0.044615. So kindly counter check with your own calculators as well. Okay, so meaning our confidence interval is here. So we just have to add that thing, subtract it, and then we have our confidence interval. So our confidence interval will be 0.4 minus this. I round it off to 3 significant figures. I get 0.355, comma, okay, and then 0.445, like this. So remember, I can change this to percentage, right? So I can say this multiplied by 100, it is 35.5% all the way to 44.5%. So that is my confidence interval there. Okay, so that is my confidence interval. And then we can answer the other follow-up question. So that was part 1. Okay, that was part 1. And then part 2, they are saying comment on the likelihood that more than 50 nurses experience back pain. So this confidence interval at 99%, okay, you see that it's way below the 50%, because the 50% will be somewhere there. But this is 35.5 to 44.5. So meaning here there is where the saying comment there, which is part 2. okay, we're going to say that the entire 99% confidence interval lies below the 50% because this is 35 to 40 to 44. Okay, so the conclusion there is that it's very unlikely. Okay, it's very unlikely that more than 50% of nurses experience work-related back pain. Okay, it's very unlikely. Okay, and then let's keep these values because I think we're going to make reference to them. So here we had found what? Calculate the confidence interval. This was the confidence interval here. Let's put it in terms of the percentage. So it will be 35.5, 44.5 like this. And then here we said very unlikely. Okay, and then from there now we can go to part 3. So part 3, they're saying suppose a follow-up study was conducted with 1,200 or 1,200 nurses. So it means my N has changed to 1,200 nurses, and then 50 reported 540 reported back pain. So my F is now 540. So it means my proportion is going to shift to be 540 over 1,200. So this one is going to give me 0.45. So you can see that from the 0.4, it has increased to what? 0.45. Okay, because the sample has increased there. So they're saying construct a 95% confidence interval for the new estimate and compare it to the previous interval. Okay, so confidence interval will be equals to okay, so we're going to say the same formula. We're going to say the proportion which I found is 0.45 plus or minus, okay, the Z alpha over 2. So here the alpha now will be Z, the alpha there will be 0.05 divided by 2 because I'm considering now a 95%. Okay, but all that is not important as long as you know this table. So at 95%, it's 1.96. Okay, so that would be 1.96 and then square root of 0.45, 1 minus 0.45 divided by the new sample is 1,200. Okay, so that is what I have there. Okay, so from here we're going to say let's just multiply whatever we can see. Okay, so 0.45 plus or minus, here I'll say 1.96 multiplied by whatever I have in the root. I'm getting 0.02815. So it means my confidence interval will be, okay, I'll say 0.45 minus this number. And then I write 3 significant figures. So I get 0.422, comma, and then this number plus this, I get 0.478. I can write this in terms of a percent. It will be 42.2%. This has to be a curved bracket, and then comma, 47.8%. Okay, so this is the confidence interval on part 3. Okay, so they said we should compare it, okay, to the confidence interval that we got on part 1. Okay, so that we see that the confidence interval for part 1 was from 35.5 to somewhere 45.5. But this confidence interval that we found on 3 is from 42.2 to 47.8%. Okay, so what can we say about the intervals? Okay, we are going to say that um the new 95% confidence interval, this one here, is narrow. Okay, because the difference between this guy and this guy is what? If I say 47.8, okay, 37.8 minus 42.2. The difference there is 5.6. But what is the difference there? That is 44.5 minus 35.5. The difference here is 9. So this one has the smaller difference, right? So it means it's narrow. It's coming together like that. Okay. So the new 95% confidence interval is narrow. Why? Because the n increased from the 800 that it was initially, it went to 1,200. Okay. So that's the first comment that we can make. And then we can also say that the point estimate, okay, the point estimate increased because here it was 0.4 and then now it is what? 0.45. So um, that's the second comparison that we can make. And then we can also say that the two intervals, okay, this interval and this interval, they actually overlap. Okay, they actually overlap. So um, the change is plausible. Okay, the change is plausible and not consistent with sample variability, but the new study suggests a higher proportion than the first one. Okay, and we can see here we have 0.45, there we have 0.4. Okay, all right, so that is that on part 3. And then now let's look at um, part 4. Okay, so here you just have to know a lot of formulas. So part 4, they're saying what minimum sample size would be needed to estimate the proportion of the nurses with work related back pain to within a margin of 2% at 99% confidence interval. Okay, so there we're just going to use this formula. So we're going to say sample size will be equals to Z alpha over 2 squared. Okay, and then I have the proportion multiplied by 1 minus the proportion. All this divided by um, the error squared. Okay, so which one is our error? Our error is what we've been taught there. Okay, we've been told that our error is actually 2%. So meaning our error is equals to 2 over 100. This is 0.02, like this. So that is our error. Okay. And then what else do we need? We need the proportion. Okay. So this proportion here, on this question here, okay, we have not been explicitly told which proportion to use. Okay, we're not being told which proportion to use. So if you haven't been taught which proportion to use explicitly, then you always use P is equals to 0.5. So why are we using P hat is equals to 0.5? Because this here is the value that maximizes. So it maximizes the sample. Okay, maximizes the sample. So uh, we're going to use it. Okay, so um let's find it. Okay, so no. Here they said we find the minimum sample, right? Okay, so if they just said what is the sample size, okay, what is the sample size? Then we'd use the 0.5. But here they said minimum. So this one maximizes the sample size. but here they're saying minimum. So we can't use the 0.5. We're just going to use the original one for the question. So the original one was P is equals to 0.4. So I'm going to use this one. So I'm going to say N is equals to Z, this squared. Okay, so we are looking at 99%. So it means our ZD is what? This guy. So it would be 2.575 squared. The proportion is 0.4. And then 1 minus 0.4 divided by 0.02 squared. So let's just multiply this. So I have 2.575 squared multiplied by 0.4 multiplied by 0.6. That is if I do 1 minus 0.4. Okay, and then I'm going to divide that by 0.02 squared. So what am I getting as my minimum sample size? I'm getting 3978.375. So this will be, if I round it off, to just be 4,000. Okay, so that would be my minimum sample size. Okay. Right, so we're done on B, and I think that's the end of question 1.